First up, we've got Charles Kubicek. Take it away.
Thank you. Right, morning. Thanks all for coming. So I'm going to be talking about data mesh at Spring and Nature. So just before I start, does raise your hands if you have a vague idea at least of what data mesh is? No. All right. Okay. Less than half. Okay. That's good to know. Okay, so just a bit of intro about me. So yes, I'm Charles. Worked at Spring and Nature for about 5 years. Before that, worked at various Agile consultancy type companies. I'm a software engineer by trade. So I'm not a data management expert. So if you do notice anything in my slide that's blatantly wrong, please come and tell me. So yeah, data mesh then. So it's a kind of socio-technical architecture, I would call it. With the goal being to simplify access and consumption of data sets around an organization. So for some organizations like ours, that has been quite a big challenge. I'm going to talk about why we're using this approach, how we've ended up kind of using it throughout the different teams in the organization, and also like what the benefits have been, what we've learned from it. Some context to begin with, because this is important. So Spring and Nature, it's a scientific publisher. So it's actually two companies that merged, Springer and Nature, and they went for the double-barreled option when they come to choose a name for themselves. So typically how it works, authors submit scientific articles, they go through a peer review process, and then the good ones are accepted and get published, and the other ones get rejected and maybe published elsewhere. So the oldest entity is about 150 years old. There's a lot of time for tech debt to build up. It's quite a highly siloed organization. So based on a lot of mergers and acquisitions in these companies, it's quite siloed. And that is a problem because from what I've seen, a lot of key feedback loops actually cross multiple silos. There's some big industry changes that are happening at the moment in this world. So a lot of content historically has been paywalled. You have to pay to access it. Now it's changing, so it's becoming free to access, but authors pay instead. So this is quite a big change, requires the ability to sense and respond to how consumers are like responding to that change. Sorry. So I had worked in part of Spring and Nature called SM Digital. So this was an area which was doing like products delivery. So based on like a lot of lean, agile practices that we had used to deliver our products. So we were fairly mature using things like continuous delivery, pair programming across the board. And the goal here is to take a lot of those things that we've learned and done well there and apply them to the world of data as opposed to just microservices and product delivery. We'd also been using cloud computing as well, so Google Cloud in most cases. So that was coming up as well. And also, although there are a lot of silos, a lot of interesting data-related work happening within the silos. So things like machine learning, data warehouses, things like that. But the data hadn't been used across the silos, and that's where we saw a lot of opportunity. So more specifically, some of the difficulties we had was that data was inaccessible to a lot of teams. So people wanted to use data to improve their products, to come up with like new ideas, to do deeper analysis, and the data was inaccessible. It was either in vendor systems that were hard to access if you didn't know how to do it. The formats were sometimes proprietary, or it was behind a database backing a service somewhere. When people did get access to the data, they found it was incomplete or inadequate for a use case. But worst of all, people didn't trust the data that they saw. So when data was coming out, if it was put into a report or something like that, people didn't believe what they saw, and they went off and got access to the raw data themselves, munged the data to make it look like a lot more like they thought it should look like, which would end up in different parts of the organization having different information in reports that should have been about the same thing. That caused more confusion, caused more people to go and build their own reports, and it just got worse. And so you end up with, untrusted information being reported. All this while, data is the new oxygen, as I like to say. So 10 years ago, it might be that data is the new gold and there's always opportunities. But now really, we need data to be able to sense and respond to our customers' needs. We had done quite a lot of proof of concepts over the years based on data, but not many of them had made it into production. So that was something else which is missing. But lots of opportunities. So as a science publisher, there's lots of very interesting data around. More teams are demanding access to more data, not just for reports, but also for different things, for machine learning, to kind of build into existing customer-facing products. So yes, lots of opportunities. So what do we need then? So when we're thinking about how do we kind of improve like access to data and use things like Google's cloud offering, we need data which is easily accessible and is trusted by people. We need something, data interoperability, as we call it. So that is data that can be joined like in the same place. We don't have to go across multiple systems, but there's one place ideally where you can use to join the data. And also ideally have the same identifiers across different data sets to be able to easily join data together. For that, we need some standards. That kind of brings us into the realm of data governance, which again have been happening in some parts of the silos and in some silos not really at all, but not really across the entire organization. And also we need technology that can work for a wide range of teams, because we have like product teams using Kotlin to build microservices, but also Salesforce, SAP, and a lot of these other vendor products that want to get in on it too. Okay, so I'll introduce data mesh a little bit next. So I should say that we haven't like copied data mesh exactly as it is written down in the book. We've kind of pulled the bits that work for us. So when I talk about data mesh, that's what I'm going to talk about. I can't really do a whole wide ranging view of data mesh because it's quite a big topic. But before data mesh came along, we started off on this kind of work of trying to make data more accessible. And the goal at the beginning was put everything in BigQuery, which sounds good, but then what, right? We don't want to have this kind of like throw it over the wall and hope that, you know, the data magically kind of like results in interesting analytics and insights, because it doesn't really work like that. We don't want to build a data lake that's unmanaged and ungoverned, because that's how you get a data swamp. Instead, we wanted to retain ownership and accountability of the people who generated the data in the first place. It should really belong to them, and they should have an understanding of how their data is used. And most important for us was to ensure interoperability. So while data is going into Google BigQuery, for example, so a lot of people can see it, it needs to be in the same geographical region. Otherwise, you can't join the data. So just a bit of terminology. You can kind of think about data in two types, I suppose. So first type, operational. So this is data which is connected to live systems, so websites or internal tools. So in those databases, they need to be fast, and they're like quite lean. They have just the data that's needed for that service to deliver what customer needs. And on the other side, there's analytical data. So this is like the data warehouse style thing, which is like exhaustive, has a huge amount of data in it, but it's typically quite slow. So this is about really how we manage data on the right in analytical world, but also how we bring those two worlds kind of closer together. So it's not a throw it over the wall type thing from operational teams. And this is quite familiar. If we've worked in DevOps in the past, where we've figured out how we can build like platforms to enable operational teams to use sort of operational tools and technology more effectively. And I think it's a similar kind of pattern here. So yeah, when we started this work, we started thinking about data pipelines. There's a lot of water analogies in the data space, and this is one of them, the lakes and things like that. So when we started thinking about this, we realized we need these read-only replicated data sets from operational data stores in the analytical data stores. So this is a one-way continuous data transfer from a source system or a database into a analytical data store. So it's one way. Once the data appears in the analytical store, it doesn't change. It's like a kind of functional type immutability situation where the data goes in there, can be transformed into different views, but it's immutable. It doesn't change. You don't modify data in there. So if you need to change data, you change it in the source system. The data never goes back from analytical into the same source system. And it's not integration through the database. It's a one-way push by the team that owns the source system or the database. And what we're talking about here is like typically tables. You can think of it in terms of like SQL tables being moved across. Other teams use different types of databases, documents, graphs, things like that. But ultimately, in our analytical data store at the moment, it's tables. So yeah, this had been going well. We'd started it. I think we were missing kind of like a conceptual foundation to describe what we're doing more widely to the organization. So thankfully for us, at the end of 2020, this data mesh term appeared. So it was a series of articles written by Jamek Degani. Yeah, and this kind of like laid out this architectural idea for how you can move beyond a monolithical data warehouse to something that's more distributed and more domain orientated. So there's 4 principles that kind of guide this: domain ownership, data as a product, self-serve data platform, and federated computational governance. So I'll talk about these things. Yeah, but with reference to how we've adopted them in Springer Nature. As I said before, we didn't kind of just go and copy this stuff. We've like applied it to the context which I talked through before. So data mesh, Springer Nature parts. So yeah, the first kind of concept is, I think for us, was like the most impactful, and this is to treat data as its own product. So it's not a byproduct anymore from an operational system. It's actually part of a team's offering. It's something that they offer to the rest of the organization. When I talk to service teams, I kind of compare a little bit to an API. So it's something that a team would kind of expose internally for people to use, but instead of a request response style thing you'd use for a web interaction, it's a continually growing like data set. And the idea is that you could do select star on this data, and you can understand a lot about it in one go. Yeah, so the reason that it's a product is like it's an emphasis on understanding user needs and almost like a marketplace within the organization for how this data could fit in, and understanding exactly like what users could do with this data, because that's one of the things we've seen. People see many opportunities for kind of joining data sets from within the silos that haven't been joined up before. The goal, yeah, is to simplify consumption. So if somebody wants to use a data set, it's kind of there, waiting, ready to go inside Google BigQuery. And they don't have to go back to the raw data system and build their own integration or worse, hack something together. So the other concept is domain orientation. So broadly speaking, you can think of a organization as kind of split into multiple areas that kind of correspond to individual parts of the business. And the data mesh, well, meshes those organizational parts together based on data that's exposed, so they can make use of each other's data. But more specifically, I think more interesting for us is to think about bounded context of data. So in this diagram that I stole, it kind of shows how customer entities exist in different bounded contexts, but they actually serve different purposes. So it's the same customers. So you would use the same identifier, so you could link these entities across the bounded context. But within something like support or sales, there's actually quite sort of different entities and different bits of information linked to a customer. Even down to like an address may actually appear different in terms of support or sales. And we've seen this problem happen even inside individual systems. There were actually different bounded contexts that people had, and they're trying to modify the same data in the same system and kind of stepping on each other's toes quite significantly. So next part is self-serve data platform. So the idea of this is to reduce cognitive overhead of teams delivering data as a product. So typically this is built on a cloud platform. Now on all the main cloud platforms, there's a very rich set of tools for doing a lot of data and analytical work. So we don't want to reinvent any of them. Instead, we kind of want to kind of like thin platform, or a thinnest viable platform, which is something from the team topologies book, which describes that, you know, what we need to do is just come up with some standards for how people use the tools and technologies to make it as easy as possible to do the right thing. And really for us to make sure that data stays interoperable. That's one of the key parts. So that involves standards, and that's what our team is looking at. How, what are the standards teams need to follow in order to effectively use something like BigQuery and the other tools. Yeah, for us also important is we want like one analytical data store, one integration target that all of the different teams can use. So for us, yeah, at the moment anyway, that's Google BigQuery in almost all cases. And also with BigQuery, it actually uses different stores itself, so it can consume blob data, for example. We have a platform team which is doing this work. It's also doubled as a enablement team. So people in that team are actually working alongside the domain team on use cases to understand how to deliver data as a product and better enable them to use data in their services. So far for us, it includes quite a mix of things that we've delivered. So things like best practices, Terraform modules, data quality tools, little websites we can use to share bits of information. And then finally, a bit of a mouthful, federated computational governance. So I think the important bit here is that instead of having data governance as a centralized kind of like department or thing, most responsibilities federated out to the domains. The theory being that the domains understand the data best in a kind of centralized kind of entity and are best to take some of the decisions when it comes down to who should access what data. Also, a big part of this is a focus on retaining data interoperability and building trust as well. So initially, when we started talking about governance, it was just quite simple things. It was make sure the data is in this region in Google BigQuery, make sure code is in GitHub, because a lot of data pipeline code wasn't. So it was hard to see how data had been transformed. So we asked that people put the code in GitHub, so it becomes a bit more transparent as to how data is being transformed. And that goes towards building trust. We also work closely with data providers and consumers to make sure that we're not doing anything daft. And also, most importantly, the data privacy people to make sure that they're aware of what we're doing and we're not kind of exposing data incorrectly. So I'm just going to take a drink. So I mentioned before that data as a product is probably the most impactful concept for us. So I'm just going to talk about that in a bit more detail. So just to recap, we have operational systems that are producing data through their operation. Users are interacting with them in various ways, and we're collecting information. That information is then pushed into an analytical store, BigQuery in this case. That data has appeared that remains owned by the same people that own the source system. It's another part of what they do, basically. So in the book, they talk about, or she talks about three types of data products, which I'll go into it in a bit more detail. So the first type of data product is known as source aligned. So the idea here is that it's kind of what I described before, that the source owning teams have responsibility for pushing data and is closely aligned to the source system. I refer to this as like the data being connected into BigQuery because there's a schedule which is defined as part of the contract of the data product. So it's updated every day or like whatever it is. I should say, yeah, it can come from a source system or it can come from the database, depending on the team. Some teams already publish like domain events of things that are happening, so they can go straight into Google BigQuery. And I would say that's like the gold standard of this analytical data. It's events that are happening that can then be aggregated and joined in certain ways. In a bit more detail, then these pipelines, like the way they look, there's like various stages to them. So we have a source system, which may be a database linked to a change data capture system, and that data is then kind of synchronized into the first stage of a data pipeline, which is a raw area. So that's a table containing data kind of exactly as it is from the source system. So it's a very kind of like dumb synchronization. There's no logic there. It's just a synchronization of data, and that raw area remains private to the team. From that point, it can be transformed into what's known as a staging area. So this is where most kind of logic happens. So it's things like validation, filtering of certain information that may not be relevant, aggregating certain data sets depending on what the needs are. So that's where like a lot of logic happens. And then the final stage is transforming those staging views into the presentation view. And that's like the data product view that consumers end up using. So there are multiple of those product views for different use cases people have. In some cases, this data is large and very complex, and some of those aggregations are best done, again, by the domain team who owns the data, who knows the data the best. And typically, over time, as more people start to use this data, they end up being able to use views which already exist. And yeah, I would say, yeah, as I kind of mentioned before, it's kind of technology agnostic. The most important bit is this data appears in BigQuery and it's usable. How that actually happens is best left to the source system owners, and how they choose to integrate with BigQuery, because for different vendor products, it's done differently. And yeah, but the idea is if a team can connect to BigQuery using the various integration points it has, they can start doing this, which is pretty much most teams. So the next type of data product which we use is consumer aligned. This is a data product that's been designed for a use case within a domain or some part of the business. Yeah, it's assembled for that use case. One of the interesting things about this, though, is it can use existing data products as a source. So it doesn't have to go back to the source system all the time. It can use data products that are already there. It saves an awful lot of time and effort because the data products are already in BigQuery. It's possibly private to the domain as well. But although we have the like this pipeline here, which starts with like the data product, lineage plays quite an important role. So lineage is being able to trace data back to a source. And this is built in now to Google Cloud and to DBT, one of the tools that we use. So it's possible to understand, where data, which source system piece of data originated from. So if you have to go back to and maybe talk to them, it is possible to trace that back. So inside a consumer aligned data products, things can get quite complex because there's quite a lot of inputs to different like data products, internal systems that may be involved, and also things like spreadsheets that are used to configure various kind of filtering options or segmentation. So yeah, this is kind of what it looks like inside. This is a very sort of simplified version. And on the right are the data products that get created. And in some cases, those data products actually feed back into other operational systems within the consuming domain. Even more detail, this is an actual consumer aligned data pipeline. This is the lineage of it going back to the source systems. I don't know, hopefully you can see it well, but the blue lines are intermediary tables or views that are used during the transformations. The last two at the very end on the far right-hand side are the actual data products that have been created. The green rectangles are various source entry points. And you'll see there are quite a few of them for various kind of like configuration inputs. And there are quite a few kind of blue ones which end but aren't actually data products. And they are things like tables that we use for various kind of monitoring kind of things, or for debugging. So if people want to know exactly how a piece of data has been transformed, it's quite useful to publish a kind of intermediary table to show what's been going on. So yeah, it sort of grows quite large. So there's a third type, which is called aggregated. So this is a kind of typical 360-degree view of a customer. So hear about this quite a lot from vendors who want to kind of like pitch single source of truth for everybody, which sounds highly appealing, but it comes with certain problems, I think. So again, I mean, one of the goals of data mesh is to move beyond the kind of monolithical data lake, as it's called. And this is pretty much exactly that, the thing we're trying to get away from. One of the main problems is there's no owner. It kind of sits in the middle. It's not a source of truth. It's just another source of truth, which I think, causes more problems than it solves because it has a lot of uncertainties about where to go to for data. So this kind of product requires like a lot of, I think, quite heavyweight governance to make sure that people can only go to a certain place for data. It also introduces like a lot of tight coupling as well to certain ways of representing data that may work for one team and may not work for some other team. So I don't think it's bad to aggregate a lot of different sort of data together, but it's best done in a domain. So it's very clear who's owning it and what they're using it for. I don't think it's bad either for multiple domains, for domains to have their own views of customers as well. As long as they don't necessarily have to share it, they can use it for their use cases. And yeah, as long as lineage is kind of retained and it's important and people know where the data's come from, I think that's okay. Just not centralized in the middle of everything. So yeah, this is why we chose to go down this path. I think it's met a lot of our needs and problems we had originally by having this kind of standardized data product idea in BigQuery in our EU region. We've met the goals of the data being easily accessible because everybody can use it. The data is then interoperable because all these data sets are in BigQuery. They can be joined, they can be transformed. Most teams have been able to connect easily to BigQuery. And also they can measure data quality because the data's there. They can select it all and they can understand before they commit to using it whether or not it meets their needs and whether or not they need to have further discussions with the owning team about how to improve data quality. And just the simple things like putting code in GitHub and having lineage and talking about data ownership kind of helps increase transparency and moves people towards trusting data more. Okay, right. So that's kind of why we're using it. This is more like the how we've actually gone about implementing this in our organization. So what we've done is start with a few examples, a few use cases for how we do this. So these kind of include building new end-to-end solutions for opportunities which we haven't been able to do. So we've worked with various departments in the organization to build these like full pipelines and understands, how people would use these data products once they're in BigQuery to deliver new features or new methods of communication with end users. So we had to start with quite low quality data. So data from within the silos. There was a data warehouse we used, but turned out it was really full of like financial data, but it was useful to us. So we just started using it. We referred to it as Band-Aid data, but it was good enough to get started with. And the idea is to do use cases which cover the most valuable data sets in the organization, the ones that people keep asking about. And we do this to establish various capabilities. So on the data provider side, the data consumer side, and like across the organization to establish how people can use data more in their daily work. So this is kind of like how it went. There was a domain team that we partnered up with. We had this dump of raw data, which we eventually managed to get into BigQuery, but pulling data out of vendor systems into BigQuery is sometimes a massive pain. In this use case, we were the first team that the vendor had come across to ever do this. We also partnered with some outside experts in the domain to figure out what use cases we would be able to deliver. So this was with a marketing team actually. So the first thing we did was find the team who should own some of this data and work with them to introduce the data as a product idea with them. So they weren't a technical team, they were more of a data analyst team. So we had to work with another consultancy to help build pipelines from the source system into BigQuery, and then we made them the owners. So yeah, I mean, the good thing about this is that data is there now. It's available to anyone in the organization to use. It's a really important data set. And that team is like now drowning in support requests, basically, because it's really popular. So I think that's for another talk. But it's like definitely been successful. And then so within our use case, it means we can consume from that data as a product instead of this raw data that we found. So as we continued on, we worked with the domain team for them to establish like their data sets as products through the use case. And one of the things we did with them was like to be able to measure the impact of like the things that we were doing. So we were using the data we were getting from sources to provide better communication to end users. So more timely information about when they could submit to journals, for example. And then we could actually measure the impact of that information that we were giving out through this system. And one of the things this allows us to do is have a very quick feedback loop from the domain team when they make a change, to be able to measure it and then to course correct or what they're doing, or to think of new use cases based on like the data that they found. And I think this is a really important part of it, because like I said before, a lot of feedback loops were going across silos. So that means data was being handed over to some other silos to do some data analytics on. Someone else is building a dashboard. It gets presented. Someone else copies data out the dashboard. Maybe it appears in a mirror board later on, and then someone uses it as a vision. And the feedback loop is long and painful. So if you can keep this like data-informed feedback loop within a team, or at least within a domain, it speeds things up a lot. The other thing we were doing a lot of is data analysis. So we had a embedded data analyst from the domain team working with us. So they are constantly looking at the data coming in, running short, or well, it depends on like what we can do, but in some cases long experiments to understand whether giving users certain bits of information has a impact or not. So there's a lot of like segmenting data based on what we think are useful domains, so we can say send different messages to one user group over others. And a big part of this was data storytelling. So we're not building a new product or a new feature on a website that people can easily see. What we're doing is like refining the information that we give to users so they can make better decisions. And that's not as understandable as I think that's what we found to a lot of people in the organization. So being able to kind of like explain to people how the data is impacting the information that we give out and the effects of that becomes very, very important actually. And where we've been missing that, it's been very hard. So just to talk a bit about the technology that we've been using. So I mentioned BigQuery before. So it's a serverless storage and compute system, which is great. It's complete serverless, which means we don't have to like have a operations team run it for us. We just have to pay the huge bills instead. So it's great because there's a API for everything. So as a software engineer coming to this, we can have like full control over what we're doing. And it means we can use tools like Terraform to provision various parts of BigQuery and other surrounding infrastructure we need. Within BigQuery, we treat a data set as a product. So a data set is a collection of tables and views together. And we use what's in Google. They have tag templates. So we can attach templates to various sort of data assets to hold bits of metadata that are important, like who owns the data set, how to get in touch with them, what the access control kind of things are with it. And yeah, that's like been quite important for our data catalog. So we used Google Cloud Catalog as a backend to our catalog. We built our own custom user interface on the front because having talked to users, they needed something a bit simpler and a bit easier to understand. So that's something we're working on at the moment. And then for running the SQL in BigQuery, because it's based on SQL, we use a tool called DBT. So DBT is the data build tool, it's called. So it's a command line tool for executing SQL-based data pipelines. It makes working with BigQuery an awful lot easier. It kind of has a view of like SQL scripts as models. So these are just files which can be checked into GitHub. It has macros, variables, lineage out the box, which is what I showed you before. And with all these tools, it means we can do things like unit testing. We can have feature toggles. So it means we can like retain all of the kind of best practices which we'd established working in SM Digital. So CI/CD, trunk-based development, test-driven development. We can do all that in the data world. We typically run it in Airflow or Cloud Run. I think they do have a cloud offering as well. So yeah, it's been great. I think Google also have an equivalent tool called Dataform, but we've ended up using this open source offering just because we could possibly link it out to other data technologies, and we just liked it a lot. Okay then, so some lessons now, lessons we learned. So lessons around data as a product then. So these data products really enable us to go faster and make things simpler. So in the use case that I mentioned before, it took us a long time to get the first data product kind of like working to a point. It took 14 months overall. Second data product we integrated took about 8 months. So this is kind of like convincing the team that this is a good idea and they should do it. That took a while. And then for the third one, that had already been delivered as part of another use case that we were working on. So when we came to use that data, the data product was already there in BigQuery, ready to use. It only took us 2 weeks to integrate it into the pipeline and get it working. So the more of these data products that there are, like the faster this work is going to become. So yeah, the interesting thing we're doing here, there's like lots of use cases for this data. I mean, typically as like standard analytical use cases of building like reports and like being able to predict things with machine learning. But what we were using it for was actually taking the data and using it in other operational systems to send out marketing messages, things like that. The kind of begs the question, why don't we just stream data directly into like the operational system from a source? Of course, you can do that. But I think this rich data analysis that we were doing is like quite important to be done like in one place. So you can just do anybody can roll up and do a select star to understand more about the data that's there. I think that still needs to be in place in order to build trust and understanding in this data that we have here. So incentives. So one of the things that I continuously run up against when I was doing work with data is going to a product team and saying, can you please export your data into BigQuery so we can use it? And I only ever got one answer. And you can guess what it was. It was a big no. It's not on our list. It's not on our OKR. It's not on our backlog. Who are you even? Go away. So, I think, like the goals were like trying to build a self-sustaining socio-technical architecture here, right? And I think the best place we can get to is that each team, or at least each domain, is using data that it produces within itself to guide where it's going next. I think if we can do that, then you kind of have to export the data. It just has to be part of how the domain operates. That's not really how a lot of teams have been happening. That work is done by other silos, and I think that's what's created a lot of these problems. What we've done instead, though, is a bit of gentle naming and shaming to kind of like measure the progress of domains publicly in a forum where there are important people. And I think that kind of, because there are different silos working in different companies with different cultures, that resonates with more people, that like way of working. It's not what we want to do, but sometimes that's what we have to do to get things started. The other thing we're doing, though, through our data platform is reducing the friction to actually create these data products in BigQuery. So making tools and services to make it as easy as possible and less kind of mysterious for developer teams to export data and start managing data as a product, because it is something quite different. So we have different types of source system. Obviously, we have systems we built in-house and things that we bought from vendors. And we found that the systems built in-house, those teams have a lot more like natural ownership of the data in those systems. When we start talking about who owns it, it's obviously them, because they designed the schemas and they built the systems that are populating those databases. But in the case of vendor systems, it's not as clear. The whole point of those vendor systems is to offer like processes that we kind of buy, and we don't have to think too much about the data underneath it. So when we're talking to those teams about who owns the data, it's not clear. So that's been a bit of a problem for us that we're still working through at the moment. But an important part when we're looking to buy tools is that we can easily export data into BigQuery, and we don't have to wrestle with various systems and difficult integrations. So a few more lessons now about like data engineering and things that we learned there. So what has been different with data? So I think when we first started doing this work, we came from SN Digital. We'd been using Kotlin quite a lot, so we were doing Kotlin to do most of our data pipelines. And it turned out to be a massive pain, right? Huge amount of code, all of this logic. And then someone said, why don't you just use this thing called DBT and SQL, which originally I didn't really think much of, but when I actually tried it, it's like, oh, this is so much easier. Instead of writing 300 lines of Kotlin, it was 30 lines of SQL. And we could check it into GitHub, and we had all these tools with it. So that became a win quite quickly, actually. It did take a bit of getting used to, though, I have to say. But yeah, it's all good. So yeah, the kind of data teams that we kind of built through our use cases are multidisciplinary. I mean, most of our product teams are as well. But I think here it's kind of interesting, because when we're doing end-to-end delivery, there's a lot of software engineering for the integration side of it. Then there's like what we've called analytical engineering in the middle. So this is like people building dashboards, working with SQL directly, but not really writing code to kind of do like their sort of platform. It's like the Terraform infrastructure or kind of integration points. And then on the end, there's like data analysis, which is really just SQL. And yeah, I think that, as I said before, that kind of data analysis and role of like storyteller ends up being really important. And depending on where a team is, like what are the source systems it's using, there may not be any software engineering at all. So that was quite interesting. So how things fail in looking at quality is similar in some ways. So there's still a lot of unit testing, a lot of integration testing. There's less manual testing, but then we have like the data analyst person who's like continually looking at that part of it. What there is an awful lot of, though, is contract testing. So treating data coming in and sort of verifying that it meets a contract or a certain expectation of the consumers. So this goes into remember data quality, which I'll talk about soon. But yeah, using DBT, it makes it quite simple to do quite complex contract testing. So you can sort of test values within a table or across tables and then understand if some contract is broken. And then you can alert on it and figure out what's gone on. You also have to figure out how to deal with things that break in a pipeline as well. There's various options because you can kind of stop an ingest if something's gone wrong, or you can just maybe like stop one particular row kind of going into the analytical data store. It sort of depends. That decision has to be made. So just a bit about data quality then. So again, this is a huge topic. I think historically data quality has been seen as almost like a centralized thing that a governance team kind of says data quality must be at this level for this particular data set or this level here. But for us, we've really left it up to like the use case teams to decide what the data quality needs to be for what they're delivering to end users at the end of the day. So data quality teams build like their own dashboards like this, where they can kind of like eyeball it and measure the data quality alongside a lot of other sort of systems that we have to alert when something is broken. Now, I mean, if something's wrong with the data, it typically indicates that there's a process problem somewhere, something else is broken. And the good thing about treating data as a product and having this kind of shared ownership thing is that if something's wrong with data in a data set, it's the same people who own that data as who own the source system where the data come from. And they are then empowered to fix the process problem that caused the data quality problem. And that's where data quality problems should be fixed in the source system, not the analytical system. Last slide. Oh, second last slide. So obviously I can't show up and talk about data without mentioning AI. So I'll say a little bit. I think as ever, your AI or machine learning model is only as good as the data that goes into it, or like the data mesh. So I think like all the cool stuff that's going on, they don't change the fundamentals. You still need to put a lot of care and attention into your raw data and how it's managed and shared across your organization. We can use AI for a lot of work that we do, like potentially generating descriptions in a data catalog that people have been too, sorry, I was going to say lazy, but people haven't had the time to do. And also, I think, like what is your raw data changes in terms of like large language models? Because all of a sudden, all of the documentation you have lying around is potentially raw data to go into these systems. So just a few takeaways in the last few minutes. Yeah, I would say your important data, your key data, treat that as a product in your organization. Try and get your stream aligned teams to start using the data that it produces itself. I think that's how you kickstart this whole process. To standardize on your data platform infrastructure, make sure all the data is in the same place and you can join it easily, low friction as possible. Data governance is important, but use just enough of it. We have some problems with that. We have a lot of autonomous teams in our company and they love their autonomy a lot. So as soon as you mention governance, they tend to run a mile. So you have to be quite careful with that. Use cases, you should keep them simple. Don't go straight and hire a load of data scientists. I mean, that is an option. But I think, start with the data engineering first and make sure that, the right data is getting to the right people. And also give DBT a go because it's a pretty good tool. And that's it for me. Thank you very much.
Cool. We've got a few minutes for questions. Any questions? Let's go here.
All right. Hi, I'm Sean O'Neill. Great talk. Thank you.
Thank you.
I'm interested in how you prioritize of all the possible data products.
Yeah.
How did you prioritize the first one, balancing between demand for key business question answers versus supply of source teams willing to participate? And what did you learn along the way?
Yeah, so we started looking at data that was about our users. I think that's the first thing that we want to do, and how they were interacting with our kind of main systems. So that's what like people wanted to see. And they wanted to see, a sort of joined up view of that because we have systems that are strewn across our silos. So they wanted to see, in some aspect, the kind of merged view of that. So that's kind of what we started looking at with our use cases. There's still a lot of teams that like want access to data, and there are like other groups around the organization doing analytical work. So they were still doing that in the meantime. I think what we were giving them was just better, more complete views of the data sets. Does that answer your question? Thank you.
Next question. Yep.
Thanks. That was a great talk. You mentioned having data analysts working as storytellers, and I couldn't tell if they were being placed into the domain teams or whether they're in your separate like data platform team. So I'm curious about the separation and responsibility between the domain teams and the data platform team.
Okay, so the data platform team acted as a enablement team. So the data engineers were working alongside people in the domain kind of team there. So the actual data analyst people were coming from the domain and working alongside the engineers. That's how it was working.
Thanks, great talk. How do you reconcile the need to users to self-serve data with access controls? And have you automated that process, or do you still have a manual approval there?
Yeah. So at the moment, it's still quite manual, although it's like down to the data owning team to decide like who gets access. Our goal really is to make as much data as possible, as open as possible. And when it comes down to data that like we can't share, in some cases we just can't share data at all. But in other cases we can mask it within BigQuery. So certain columns will appear as like gibberish basically, and only certain people who have got rights to see that will actually be able to see it. So there should be practically no one seeing that data other than the machines doing joins, things like that. That's where we're going towards.
One more question. Oh, two people put their hands up over there. We'll go for these two.
So a lot of what you talked about was domain events of, I guess, database-oriented data and all for internal uses. I've seen data mesh try to be applied to a case where it's sort of imaging data that we're producing for customers. And, that just doesn't sort of really seem to fit. Based on what you know, does that seem like the sort of thing that data mesh is meant to tackle? Or is it really that it shouldn't have been used like that at all?
Well, yeah, I mean, for us, it was really to have a better organization for sharing data internally for use cases. I mean that data is, some of it does eventually become customer-facing data, but the goal is really just to make it as frictionless as possible for people to deliver those use cases. We have just been working on like data that's in tables. We haven't really looked at like image data before. It has come up, but really I think that's a sort of operational system kind of thing. I don't think it comes to data mesh, but it could certainly do though. I think you can pull attributes out of images, and I haven't really thought too much about it. We can talk afterwards if you want.
Okay. Hi, thanks for the great talk. I'm just interested in DBT and if that's what you use for your transform step for cleaning and munging data together. I was just wondering what your thoughts are in comparing it to something like pandas and Python, and what your experience is between the two are like.
So I think we try not to do much like data munging. We don't want to make things up. Like most of the transforms are like SQL transformations. So they're in Google Cloud. They're very, very fast. We have some pretty large data sets. They go into the multi-billions of rows. So using Python is a bit slow for that kind of work. So we try to do as much of that logic in SQL as possible. Obviously, when it comes down to looking at kind of like deeper, richer insights, then you have to start using some of the Python tools. So it's just the right tool for the job, really.
Okay, thanks for your questions. Thanks very much, Charles.
Thank you very much.